Hello friends, so today we'll talk about couple of AI models and then local implementation, one demo of RAG, retrieve, augment and generate, and the local implementation, the cloud implementation, and we'll see the benefits and let's get started. So Olama is a website basically, and then they support different type of AI models and which we can use locally. We can use the local language downloaded or local LLM or the cloud LLM, similar to what we use for other popular models like Gemini or ChatGPT and maybe Perplexity and other things. So we will see the simple Olama demo, how it is at the moment good alternative for OpenAI Gemini for your local development. So we'll see the download installation steps, then pulling a model on our local. What are the pros and cons, and then AI model, using the AI model from the cloud. So this is the AI model I'm using. If you see the 120 billion parameters count, it has given this that much strength. Again, the pros and cons, and then cloud model, the free credits what we have as at the moment for Olama, and some sign in sign out steps. Okay, so download and install, so pretty much simple. We'll go to the website, click on download. Yeah, download for whatever Windows, Mac, Linux. Download, install, just simple, next, and you have to then log in. So I have logged in with Gmail. Now at the moment, if you see, I have logged out. Okay, let me log out. Okay, so I've installed it on local, and the simple UI looks like this. Okay, if you are not signed in, simple UI looks like this. So we'll do a sign in. So we can do a sign in from here with Gmail and all, or we can click on the link. So I have this command prompt. It's a PyCharm ID, but it's just basically for now it's just a simple command prompt. So I have logged out, so I will do a login. So for that, after Olama installation, you can simply say help Olama space help minus help. So here there are typical commands. So I have done a sign out. Now I will do a sign in. So sign in. So simply to give an URL, and you have to copy paste this in the browser, and we should be able to log in. If not, we will log in with Gmail. Yeah, log in with Gmail. Connect. Okay, so it is connected. Now we'll just do a refresh. So it is logged in. Okay, here also on the command prompt. Okay, so you're already signed in. Okay, fine. Now login is done, installation is done locally. Now which AI model we want to work upon? Now let's see that. So for that, so there are a couple of AI models which we can download on our local and then do the local development, which is independent. There's no internet connection and nothing like that. But the thing is, I'm using my personal laptop. But if you are using personal or your corporate machine, there are limitations of how much RAM available and what is the CPU. For many of them, MacBook it runs fine, but on Windows or on the little older laptops, it may spike your CPU. So if you see the memory, as of now, even I'm not using um, any Olama, anything query I've not raised. Still, the memory is almost, you say, 86%. So CPU currently it's 45%, 70%, but we will see the spike later. Okay, so if you have that much hardware available, you can pull any local um, uh, locally installable image and you can start. So if you see the one which are cloud, those are remote images, and the one which are not, obviously you can do on local. So the one thing to note is we can download a very small image on our local. The image size is very small, and it may not take much of the CPU and memory. But again, the issue is it may not give the full-fledged output, because it might have many less parameters to be checked. For example, if it is 30 billion, instead of that, if you just use a 4 billion, 5 billion parameter combination, then it is a very amateur image, so we'll avoid that. So now this is the one I'm using for now, GPT OSS. So if you see, this is cloud, so I can remotely access this. I mean, I can say to Olama, I want to access this, and my queries which will queries will be sent to this particular image via API. Okay, we'll be doing API. Now if you see Gemini or ChatGPT, so here it is everything from UI. You can do from API, but that will be paid. So Olama has a little sweet spot that it allows you to use the uh, remote AI images, uh, not completely free, but there is a credit. So I'm using this one, GPT OSS. This is the detail page, and I'll be using this 120 billion parameters cloud. So if you simply install this one, Olama run GPT OSS, it will be simply this default, which is 20 billion, but I want 120 billion, so I'll be using this. Okay. Now, if you see here, uh, the usage. So this is the thing. Now Olama allows us to use the remote images to a certain extent, and after that it will be billable. You have to pay for it, but for small study projects, it's very easily we can use it. For now, if you see, I'm trying couple of things. I tried, I think, maybe 150 queries. So it is still daily is 6.9%. So that too, I'm using it for this 120 billion. So it is not, it is almost cheap. Okay. Now, so installation, local model pooling. So this model, okay, so this model will be running. So how to pull this using command prompt? So simply come here, Olama, run and paste. Right, that's it. So it will download that particular AI model on local. Okay, and for now, I will exit and I will simply say Olama list. So it should give me the list of the models which I have used for local. So if you see, there is no size because it's a remote model, but the thing is it is having a local uh, presence, that whichever queries will be sent, it will be sent for this particular model, AI model. Okay. Now cloud model, yeah, we have seen the free credits and all. So yeah, if you want to do local development, again, pros and cons. Pros is basically it's all independent, no internet connection, everything on your local. Cons is basically high CPU, high memory utilization. So sometimes your system may get hanged, or it may heat up, and it's difficult to stop it. You have to restart the laptop and so on. So if you are using for cloud, yes, the speed is one factor. The cloud will respond fast. Cons is basically, as of now, no cons, but yes, after a certain limit, it is a paid one. You have to pay for it. Okay. Now we'll go move on. So we'll see the simple RAG demo, retrieval, augmented, and generation. So theoretical part apart, you can search on Google. So the case what we're doing is, it is basically a PDF interaction, PDF file or text file, or for that matter any simple file, Excel file, and so on, Word file. So for now we are taking a PDF file. So it's basically some help text, and we, based on that help text, it will do a retrieval, it will augment, and based on our question it will try to answer. Okay, so retrieve, read the PDF file, or find the useful info from the input data. Augment is basically chunking, and add info, knowledge of the AI. Generate, answer the question or generate better response. Okay, so first we will see some infographic. So understanding RAG. So again, it's very quick and crisp explanation. RAG, so a method that combines external data retrieval with AI generated response. So retrieve, augment, and generate. There are some advantages. So access real world data, reliable and relevant responses, and improves AI knowledge. So for me, this is important. Many times we don't have proper answers, or we have to search a lot of data. So for that, this RAG will give a reliable and relevant response most of the time. And common use cases, yes, customer support. So there is a to do, or there is a standard help available. So customer is going to ask questions, so you have to make it generalized and then answer the generic answer as a generic answer. Okay. uh, Enterprise search, research analysis, knowledge management, so on. Okay. Now in RAG we have something called as chunking, and we have something called as embedding. So quickly, chunking is basically the process of breaking down the large document into smaller manageable pieces called as chunks. Okay. Yeah, so the robot is doing everything is chunking, basically categorization and all, and then based on that it will try to answer, it will give a better answer. Now the case study what we are taking is basically, I've taken this Amazon help for EC2 instances. Okay, EC2 types, just the instance types. Okay, and this is I think 623 pages. So if somebody wants to know different type of instances and maybe have some questions, uh, so I'll have I built one RAG, or basically a chat support kind of thing, where you are asking questions and it will try to answer with a better response. Okay, and so on. So obviously for human it's not feasible most of the time to go through each and every page and then try to answer. So let's build a RAG. Okay, right. So this file, so before that, uh, okay, embedding we'll see. So basically related to um, chunking and then embedding. So embeddings are mathematical representation of text that capture the meaning and context of information. Okay, convert, retrieve, and augment. Okay, so yeah, so we'll see the case study. Um, okay, so before that, so in AWS, so I've taken the ADF README file from the help file from the AWS website, and some documentation. So what we are going to do is we are going to ask 15 questions based on the PDF uh, to Google Gemini AI. Okay, and get the question answer. And the same question we are going to ask to Olama. Okay, so if you see here, I have asked Google Gemini. This is the help PDF. So from here, give me 15 questions and the answers. Okay, typical 15 questions and answers, and the difficulty level should be from 1 to 15. Okay, so it has given me all the questions from this PDF and the corresponding answers. Now here I have asked to have just the question and answer. Okay, but then when we are asking to Olama, we'll ask some different prompt. Now this is a prompt, basically we are asking some question. So the way we ask questions, most of the time similarly we get the answers. If you want to have quick answers, we'll get quick answers, otherwise detailed answers, so based on what we provide as a prompt. Right, so 15 questions and answers. So those I have put it in this Excel. Okay, uh, all the 15 questions and the 15 answers from Gemini. Okay, now um, now this is about the question answer. Let's say happy cases. Okay, so the question, the answer is probably there, or we can figure out some answer from the PDF. Now one more is I have asked for the uh, five questions which can be asked by a user. Okay, but the answer cannot be found in this PDF. Okay, so there might be some questions which may be out of the scope of the PDF, somewhat relevant, but not exactly matching. For example, um, how do I calculate estimated monthly cost for a M5 dot large instance? So this PDF is basically talking about the instances, okay, not their cost. So the Gemini says that the PDF provides technical specs and refers user to to the external EC2 pricing page for all cost related info. Okay, so obviously this question cannot be fully answered with this PDF. Okay, so I will say it as unhappy question. Okay, like this there are 5 questions. Okay, now so that unhappy questions also I have put it in the Excel. So there are unhappy questions and the Gemini answers. Okay, now what we are going to do, as I said, the same questions we are going to ask to Olama. Okay, and then try to get the answer for happy questions and unhappy questions, and then we'll probably analyze. Okay, compare, analyze Olama answers, and then compare both the answers. Okay, right. So happy and unhappy. Now coming to the coding part. So yeah, it's a simple project. So again, you have to log in. As I said, you have to log in with the um, you have to log in the Olama. Okay, command prompt or whichever way, and then this will start. The first thing is, obviously I have not used the local AI models. I am using this cloud one. Okay, so to this cloud one, I'm just going to ask define just one prompt or some question. Okay, define the types of numbers: integer, whole, or natural. Okay, so this is a code. This code I'll be this code is available in the GitHub repo. Okay, I'll give you the put the path in the description. Okay, so run. Now this is talking to the uh, cloud image of Olama. Okay, it might take some time, but obviously this is much faster and efficient as compared to local image. So this image up to this 120 billion I can download on my local, but if I raise this question to this, then it is minimum I'm saying minimum 20 seconds. Okay, and that is too much frustrating. But if you see the remote one, it is very quick. Okay, probably 5 seconds. Okay, so yeah, it has given me the answers. Okay, name, natural numbers, whole number, integer number, and so on. So there is a communication happening between my system and the remote Amazon image, and I'm getting answers. Okay, for now I'm not much bothered about the detail, is it correct or not, but yes, I'm getting answers. Okay, maybe what we can do, so define numbers, types of numbers in one line. Okay, run. So the prompt, what you specify, that matters. Okay, so yeah, it is very quick. Natural numbers, whole numbers, integers. Yes. Okay, so it is working fine. Now we'll come to the RAG. So RAG, I have this code where it will do it will first read the PDF file content, it will convert it into a text, basically a string, and then it will do the chunking, and then it will do the embedding. Okay, these are the internal parts. Maybe you can explore more. So yeah, chunking and then embedding. So this code is there in the GitHub, you can see that later. um, right, so for now I'm doing a prompt or a question: summarize the key points of the PDF or the main argument. Okay, so this is the PDF, the same which I was showing here, same PDF. So in this PDF I want summarize the key points. Okay, so let's run it. Now the thing is, this PDF is 623 pages, and then that data has to be sent to remote instance. Okay, and so on. So that is why it may take some time. So meanwhile, I'll explain the code. So the thing is, we are using the AI image, the one which I was showing here. Okay, GPT OSS 120 billion cloud, and then this image internally uses this sentence transformation, internal AI image, I would say, all mini LM L6 V2. Okay, This is a sentence transformation model. It maps sentences and paragraphs to a 384 dimensional dense vector space and can be used for talks like clustering and semantic search. So again, this is bit internal details. May want to skip it, but yes. So that is here. That is what it is using. Okay. So now I'm just passing the question. Okay. The prompt as this one. But if you see internally, internal prompt is bit elaborated. So there is a question, the question which I have passed. Then the context is basically the PDF file input or the data, and additional instructions. So answer concisely based on the context, answer in maximum 15 bullet points. Okay. So sometimes I would want to refine the output. Okay. So that is that thing I'm giving as an input, as a prompt, directly. Okay. uh, right, so let's see. Right, so it is given in 15 bullet points the summary of the entire PDF. Okay. You see to each family, then launching. Okay, so seems yeah, seems in 15 points it has covered a lot of things. Okay, so normally we would want to have 5 bullet points or 10 bullet points, but because the PDF size is 260 pages, I think, so 15 points are sufficient. Okay, now comes the real part. So now what we're going to do, we are going to ask 15 questions or 15 prompts. Okay, so these are the 15 questions which we got from the Gemini, which we can ask and we can compare the result. Now, in the interest of time, I will just make it, let's say, only three questions, three happy questions, and then uh, let's say two unhappy questions. Okay, so we can see it is basically running the program. That's it. Uh, so let's run it. Now, by the time it generates the response, I have already run these questions. Okay, and I got a one sample response. So happy path, I got the answer for all the 15 questions. Okay, now all the 15 questions. Now, simply if you compare the Gemini and Olama, um, you might say that it is having elaborated output or concise output. The thing is, uh, when the question was asked, when the prompt was given to the Olama, the prompt clearly said that prompt had two additional lines: answer concisely and 15 bullet points. Okay, now these were not the case when I asked the same to the Gemini. Okay, so when I asked it to Google Gemini for the first 15 happy questions, I just asked, okay, questions level difficulty 1 to 15. Okay, and just the question and corresponding answer, please, no other elaborating text. That's why it has probably given the answer, the Gemini answers in one or two lines. Okay, that's it. So I could have asked, okay, please elaborate or concise output and all. So then that might be the different case. So that is why the comparison uh, is okay to do, but it is not logical, because here the prompt is different, here the prompt is different. Okay, fine. So overall, sentiment looks good between the Gemini and Olama, or simply Olama also. Now, same thing for the unhappy cases. So for unhappy cases also, what I have seen is, let's say, Gemini clearly saying that monthly cost we cannot calculate. For example, this one we cannot calculate. Maybe you will find it in a different document. But Olama went ahead and tried some example and give us one case study. Okay, um, which may be good many of the times, but this I will not say over smart, but um, little worrying, little worrisome, because um, it might, if there are some other unhappy questions or unwanted questions or unethical questions, probably it might cook up some answer. Okay, so in that context it may not be that much worth, but in general seems okay. Okay, for example, let's take some this one. Okay, technical how do I create an Amazon from existing instance. So Gemini says, because the document is only about hardware setup or hardware thing, um, but does not contain instructions for AMI or lifecycle operation. But here, if you see, it has given the instructions um, from EC to proper details and all. So technical perspective, this looks good, okay. But again, I would say this is probably um, going extra mile to solve the answer, to get the answer, which sometimes might not be good, okay, right. So that is thing, okay. So we got the output for the happy path. Same thing I can run for the unhappy questions, and probably have to wait for 10 seconds, probably 7 to 8 seconds, so we'll get an answer, right. So then case study, we have seen the case study for AWS EC2 help PDF, and we have done the comparison, okay. Unhappy cases also we are done. So that is all about the Ollama demo. I hope you like my demo. So for more videos, please like, share and subscribe to my channel. Thank you.